Get this thing kicked off here. There we go. Looks like a real presentation now. So again, today we're going to talk about the micro PLC and HMIs or touch screens. Okay, you have to really talk about both of those when you talk about that because they intertwine so much together. But let's get started. Let's talk about the micro PLC. This is our micro PLC, but it takes the shape and form of all of our competitors. They all look about alike. Okay. And let's talk a little bit about what is the micro PLC. Well, it's a little bit of a logic controller that is intended to replace all this messy wiring and stuff down here. And it really does. Back in my General Motors days, I could replace a panel. I bet some of these things were 4 foot by 6 feet tall with one of these little PLCs like that. It's because there's so many relays in there and you're trying to do so many different things. Every time you want to add a function, you got to go get your tools out and wire it. So when they came out with the PLC and you realized you can start just identifying inputs and outputs and do all this wiring on the internal, you can do it all inside. You can change your mind and do things different without having to go rewire something. It just makes it real more intuitive. So as the diagram indicates, you got to look at we're going to be thinking about inputs and we're going to be thinking about outputs. Okay. So let's talk about that. So well, first we're going to talk about some of the advantages. So as I just mentioned, they're fast electrical panel assemblies. So if you can imagine just wiring all the inputs and outputs to the panel into one device versus all that inner wiring in between all those relays back and forth, you can imagine it's a lot quicker, it's cheaper, come out a lot better on cost, time saving, very flexible, you can change your mind. So yeah, that's some of the advantages. Where typically machine panels are where you're going to see these little PLCs like this. You get into the bigger PLCs, you're going to get more into systems and trying to control a lot bigger situation. But typically a machine, a standalone machine, or maybe some machines that can network together a little bit. But that's where you'll find these things. Okay. Again, where do we start? How do you start? I'm just going to go buy a PLC and figure out what the job is. That ain't how it works. I've worked on $50 jobs and I've worked on $5 million jobs when I worked with General Electric. And every time you start off with the field devices, okay, you got to go look at your digital inputs. These are things like switches, limit switches, things that turn off and on, okay? Maybe another relay feeding it in here. It's just another type of switch, okay? And you have analog inputs. Instead of a digital input, which is just a bit, just a programmable off and on, you have analog inputs, which is a value. It's a value. And typically these values will be a 0 to 10 or a 4 to 20 milliamp value. Okay. They even do these PT100s, these sensors, these temperature sensors. You can run these. They have cards or interfaces that you can wire these directly into the PLC. But when you do those, they're going to be a value. It's going to be a series of bits. You've heard people talk about 8 bits, 16-bit, 32-bit processors. Well, that's what they're talking about. I can bring this one value in on an 8-bit signal and get it, and it means something to me. Instead of off and on, it's how much off and how much on is it? So you get this variability. Okay, we do have some push buttons on the front of ours. And you can migrate some screens and look at some values and change some timers. A lot of our competitors do the same thing. And we also have a serial communication, okay, an RS-485. Typically, that's going to be a Modbus protocol. Everybody says, well, you got a RS-485 port. Okay, what's the protocol, the language it talks to? That's when we talk about Modbus, okay? So then you have your outputs at the bottom. You have digital outputs off and on. They're going to be lights. They're going to be horns. They're going to be motor starters. One single thing turning off and on. Okay. And then you have analog outputs. Again, they're going to be a 0 to 10 or a 4 to 20. And that 0 to 10 might be a signal. You're sending a drive to tell it how fast to go. It might be some limits for. Oh, I'm just trying to think of some stuff. Any linear signal that you can turn something off and on. Typically, they're drives for the speed. Okay. You can have messages on the display. That would be an output. You have statuses and alarms to let people know what's going on. But again, you always start with the field devices. You can't pick a PLC and then decide you're going to go do a job. You need to figure out what you're going to do out on that job and what voltage levels and how you want to control in these little end devices. And then in turn, you can get the PLC, you can match the IO, the inputs and the outputs of the PLC to determine which one you need. And then within that, you can do these logic combinations. I'm reading in the gray box now. You can put some timers. You can put some real-time clocks when to turn things off and on. Counters, PID controllers. Okay. You don't know what a PID controller is. Just probably a real simple basic PID is probably the thermostat in your house, turning off and on. Except the PIDs are linear. It doesn't just turn off and on. It has a variable, how much off and how much on does it take. Okay. So that's basic of getting started with the PLC. Some of the applications, yeah, you can do some staircase and window lighting. So I don't know if you ever walked into an area and then this whole series of lights comes on for a staircase. And there's a certain time that they go on and then they'll shut off. Okay, sliding doors, gates. You may walk up to a gate and it opens. How many times you go into the grocery store and that gate door opens for you a little bit and then it closes behind you? Pumping stations, they're sitting there monitoring when they need to turn the pumps on and off. They can turn pumps on and off. You also do them remotely. Another application is some ventilation for some air conditioning systems. Okay. Here again, we're using PID controllers to determine. You don't just turn that motor on. You might turn that motor on at a certain speed for a variable speed control. Okay. For some applications. There's some more applications. Conveyors, that's real popular. A lot of people use that. Liquid level controls, greenhouses, they have their timers that they turn their the valves on to do the watering at certain times of day. Lifting mechanisms, yeah, some more applications. Again, to get started with the PLC, you got to know the number and types of signals to be processed. Okay, types of sensors and actuators you're going to connect to this thing. Types of power supply. You're going to run this on 110 volt. You're going to run a 24 volt system. Availability of the additional modules. So we have expansion modules. Let's say you got more IO, more inputs and outputs than you have on that base module. Okay, well, we can expand that. And there's different types of programming. Every engineer has his own way of programming, and I'll show you a couple forms here. All right. Let's go to the next slide. Here is a sheet that I put together that kind of shows you. These are our module on the far left-hand side. And you got to look, okay, can I use this top one? 8 and 4. Okay, are they relay outputs? Or are they just digital signals? 24 volts coming in, or are they relay? Okay, well, I'm talking inputs and outputs, but you got your digital signals in. Okay. You got your analog signals. If I had some analogs on that base module, I'd have them listed here. And you can go to a table like this for every manufacturer and look and say, okay, well, this fit my application. After I've counted all the inputs and outputs I need, I know what type I need, I'll go select my modules off of a table, just like this, okay? Again, the outputs can have transistor outputs, or they can be relay outputs, just for the discrete ones, digital outputs, okay? Sometimes people like to use relay outputs because they isolate. You get these different voltages. Yeah, I'm turning it off and on with 24 volts, but I'm turning 110 volts off. So yeah, I might want a relay output module so I don't mix the two volts. Analogs, again, all the different analog combinations we can think of for outputs. And you'll see how many modules There's also some expansion modules that go with this soon. It'll be a table just like this. You'll add up all your modules to see if you can accommodate all this I/O out in the field for the PLC setup. Okay, let's talk about the circuitry a little bit on the outputs. Here's the relay outputs I was talking about. Yeah, this inside the black box is the PLC. And you have this little relay turning off and on, which might turn some solenoids off and on. Okay. And you can see down in the chart below, these relays are probably going to be worth about 8 amps. They'll handle about an 8 amp load. Okay. Some speeds, yeah, 15 milliseconds, turning those relays off and on because it's a mechanical thing. All right. Or you have a transistor over here could turn that solenoid off and on. Now, solenoids are probably not the best for transistors because solenoids usually pull about anywhere from half an amp to an amp and a half. You don't really want to use a transistor for that. You probably want to use a relay or have an interface relay. When you turn that transistor on, if that solenoid's shorted, it might blow that transistor in that card. Then you got to replace the whole thing. If you had an interface relay in between there, then you just worry about that. Okay, it kind of saves your PLC. But look at the transistors. Look at that. 0.3 amps. That's about the amperage you're going to get out of that thing. Yeah, it'll drive some solenoids, but it's hard on that. It's hard on that transistor. Okay. Look at the speed you get. With the transistors, you get a lot faster speeds. At like milliseconds, 0.2 milliamp, 25 microseconds. You can get some fast transistors there to do some real fast process. Okay. Just keep in mind when you're using a transistor output, they can bleed the current and turn on lights with real light loads. I don't know if you got an LED light hooked to a transistor output, like, well, it won't turn off. I get calls on this. I said, well, may need to put a load resistor by there or some kind of an interface relay to help solve that problem. But that's what's happening is transistors will bleed a little bit of current. So if you had an LED light up here that took less than what they say down here, 0.2 milliamps, yeah, it would turn that thing on. It looked like it's on. It's not real bright, but it's on. So yeah, you might need to go put a 10K resistor parallel with that light to put some load on it. It'll turn it off. Interesting how that happens. Okay. Here again, here's our base module. Our supply, this one's a 24-volt model. Okay, I got 8 digital inputs on this thing. And I've also, some of these may even have some analog inputs on those inputs. You can actually, by the program, you can actually tell it, now I want this one to be an analog. And then you can turn those last 4 into analog inputs. Okay, here's your 8 relay outputs. See how they indicate them at the bottom with a little relay looking thing? Contact closes. But this one also has the built-in RS-485 communication port. So now I can talk to a network. A Modbus network is what, 31 devices out in the field? I can talk to that and address each one of them individually. When I do that, I can not only get status, bit information, I can actually get value, status from values, a word, a whole binary word, maybe 8-bit, 16-bit, 32-bit word. That's where the communication comes in. You don't have to run all these wires back and forth between the machines. You can put one of these in each machine and then just talk through the communication to the master PLC and let it take control.
Say, Blake, just so we have some perspective, because I understand that these days these PLCs have come down in cost significantly, as have the HMIs. Can you just give us an idea of what the list price on these modules are?
Yeah, I would say you're looking definitely under $200, and some of them even under $100, depending on the volume that you're going to do. If you get an OEM that's doing a lot of these, so you can imagine if I got a panel with more than 3 relays in it, probably ought to be using a PLC because And it's inevitable, whatever you do, the customer's gonna want to change it a little bit. So now you don't have to go rewire it. You can just go change the program.
I
That's
had no idea they were that inexpensive.
oh yeah,
That's amazing.
these little micro PLCs have gotten real cost efficient. Very nice to like I said, I've reduced panels in my General Motors days down to just this one thing, a big 3x5 panel down to this little device. It's amazing all the floor space I gained out of it when I did it. People people didn't have a panel to hang their coats on the side of anymore. Again, so here's the PLC. And as you expand the module, you can add, if you need more IO, you can expand the module as they do here on the right-hand side. And as you plug these together, they have a little plug-in connector down here. This becomes your backplane. And that PLC will talk directly to these addresses. So yeah, if you had communications and you're talking to the addresses to other PLCs, there's going to be some latency due to the communications. But when you start plugging these together all on the same backplane, there's going to be a little bit of latency, but you're not ever going to notice it because that backplane's fast. They talk to each other really fast. It's kind of like having your PC and you have stuff working right off of the bus on your PC. It's going to talk fast, and if I have to talk to my neighbor down the street with an Ethernet cable, it's they just a lot more speed out of it. But that's how they create the backplane by plugging those modules together like that. And depending on how many you need, you can plug in or what the requirement, the limits are on the PLC. You can add more modules up to maybe 8 modules. You just have to look at the specifications on each PLC to tell you that. Here's some of the IO tables I was telling you about with our expansion modules. You see, I got a relay module. I've got transition modules. I've got combination modules. I've got analog modules. Got them of different types, 4 to 20, 0 to 10. Even got the temperature inputs. I have taken one of these little controllers like this. I don't know if you've ever bought a loop controller, just something to do a PID loop. You'll pay less for this with that screen. I could send you a little program that allow you to take in the temperature sensor, take in the temperature value, and adjust the valve depending on the set point on an analog output. So anytime you see a PID, you know there's going to be an analog output. That's how they work. It's a linear output. Okay. Here's a few more of our order codes. Just bear with me. I'm working off of a PowerPoint that was already created here. We have you'll want some cables. Anytime you get a PLC, you're going to want to know how to program it. Nobody really likes programming them from the front display. That's very cumbersome. Our software, most people's software is a free download, and you can download it and you can hook the cable up to it. And you can program it to the software. A lot easier. Most software nowadays has online simulators, so you can actually simulate your whole process before you even connect it. Oh, here's my expansion modules and my limits that I show. You know, I can add all these inputs and outputs. You get too many in the memory of the thing. This won't handle it. You have to look at the specifications to see what it's capable of. Okay, naturally, those analog signals, they're going to take more memory because they don't just use 1 bit. They'll take 8 bits to make that value come in. You can imagine that's going to eat up the memory a little faster. And here's most people have a beginner's kit. We have these boards like that one on the picture of the bottom. It's a board and it's got some switches on it. It even has a little potentiometer, the little blue deals at the bottom. Those are potentiometers. So you can sit there and play with it and turn things off and on. You can adjust values for the analog inputs coming in. Oh, here's just some functional diagrams we look at. There's a start and a stop, okay? And then if you looked at it in a full electrical diagram, let's look at the 3 phases, right? Feeds a motor. Well, off of a couple of those phases, you might have a switch that turns a relay off and on, starts that motor. Well, on the left-hand side, you got your switch. We don't really show you all the rest of the stuff. Just a functional diagram, which is typically what you get when you go to program these things. Okay, so you got to look at function. Look at that diagram on the left. Think about those two devices, just two devices on that one line. There's an input, which is a start button. You got to tell it to do something, and you get a result. So there's an output, that motor turning off on it. Okay. Oh, here's some more wiring where you can connect the potentiometer to the PLC, make things come off and on at certain times, certain levels. Okay. Let's go to the next one. This is the programming technique that they use. Now, I'm very fond of the one on the left. It's called ladder logic. It's just like the old relay logic when you were wiring relays and stuff. It's just, it programs the same way. And to me, it's so easy to program. If you do it correctly and you have a sequence of events, you should be able to look right down that left-hand side of that ladder logic and read what's going to happen in sequence, just like a book. A lot of people don't program that way. They kind of get into some spaghetti code like the wiring and they jump all around. But if they do it right, it's just the easiest thing in the world to follow. I mean, if something's gone wrong, you follow the sequence and you stop where the light stops. Okay. Now you get over here on the right-hand side, this is called function block diagram, and they're just function blocks. Like that first one with an I, that's an input. And then you'll AND it, just like Boolean logic. Okay, you'll AND it with this other stuff down below. Okay, so this stuff on the right is the same program on the left in two different programming techniques. Okay.
Blake, quick
Yeah.
question for you on, does Lovato offer that new standard that they call IEC 61131-3? It's
No,
the
I know what you're getting at. Yeah, it's got 6 different programming languages with an
yes, sir.
instruction list, a statement text, and all that. I've done all those. I know how to do them all, but no, we just have the 2 on these things. We just have the 2.
Good, thank you.
Typically, machine guys and maintenance guys like the ladder logic, and typically guys in the process environment, like water treatment, they like the function block. That's just kind of what follows the industry. You get into the structured text and all those other ands and or gates. Yeah, I don't. There's some very technical people that like who are used to programming in a C language or some kind of a structured text language. They like those, but I found it a little more difficult. It's less memory intensive to be able to do it that way, and it processes faster with that text type programming. But these graphic programming just makes it a lot easier for a maintenance guy. When I wrote code, I always like to set it up where a guy could go in and fix the problem really easy. And to me, that ladder logic was the easiest thing for them to follow.
One more question.
Yeah.
Do you have the ability to run simulation on the code where you can watch the code graphically on a screen to see which IO are closing and opening?
Oh, my, this thing's doing this, but yes, we do.
Oh, excellent.
Yes, we do. And I'm very fond of that because many times people have asked me to program something in my past days. I don't do that with Lovato anymore, but they've asked me to program something and I could actually simulate. Okay, well, at this point, that light should come on and I could adjust. I could do a little variable slide potentiometer in the program, in the simulator. And I could say, okay, yeah, it's going to come on at that level. I could simulate things, you know. It's not going to simulate your whole process and just make the machine run. It's going to allow you to take bits and pieces of it and verify sections of your code are going to work correctly. I did one years ago and I laid out a conveyor with squares with blocks and photo eyes. And I was showing the customer how, okay, if this eye blocks, that next conveyor should turn on. It did, it would turn dark blue when I did that. Okay, now let's force this next eye on. And we could track that part all the way through the system. Those simulators are awesome. Even our touchscreens have simulators built in them. Again, let's go back and talk about this. If the button is the input, then the motor is going to be the output. Okay? Even on your PC, we talk about inputs and outputs. So your keyboard is the input, your monitor is the output. That's the way you have to think of things. And when you get one of us nerdy engineers, that's the way we think all the time. Logic. So if I took that, where'd it go again? If I took that and converted that to a PLC language, it turns into that. There's my input for the button. I'll program that to my output. The first output, that address right after the I or right after the Q, that's the number. So if I got 8 inputs, I could do an IO1, IO2, IO1 through 8. How that works. Same thing with the output. You address that point on the card. Okay. The memory in these things. This is where a lot of people ask me to cross a PLC to a micro PLC, and it doesn't. It's not the same thing. So a lot of these big PLCs, they'll have a memory on them, 16 megabytes, 32 megabytes, gigabytes. I don't know what they're up to now. But these little PLCs, you don't really do it that way. You got to do it they do it in a lot less, they have a lot less memory in it, if you will. Okay, well, how much memory you got? Well, I can do 31 timers. I can do 31 counters. Rungs, I can do 600 rungs in it. I'm doing that. But I don't have a memory byte, how many bits or how much it'll hold. I've got a certain allocated amount of memory for a function. If you start writing a lot of code and you get twisted around, you realize, oh, I don't have any more lines of logic to add. That's kind of the drawback of the smaller PLCs, but that's where it is. Okay. So with some of the functions that these things come with, as I mentioned, the PID, they're in the middle. Okay, you can add and subtract with those things. So that's a comparison number. So if you're subtracting from a value, be it a variable that's being input in, you can set a limit. So if it meets that limit, you might turn an output on. You can compare between variables. Once these two are equal or not equal, you can make something happen. You have these human machine interface pages. This is that screen on the front. So you can put stuff up there. I've actually done the PID where I had my value going out, my value coming in, and my set point right on the front screen. It's a little bit more cumbersome than having a separate loop controller. Loop controller is designated for just what that is. And it wouldn't take near as much to set it up as you got to go in and program this into the PLC. Good programmer can do it pretty quick, doesn't have a problem. We can also do high-speed input. So if you're counting cleats on a conveyor, you're going to be looking at that speed. How fast can that thing go? Some of the higher end PLCs can get these things down into the microseconds. Multiplexers, analog ramps, ramp up, ramp down, data registers for storing values, shift registers for storing values or storing bits in a one binary word and shifting them as the machine progresses. Boolean logic blocks, that's your ands and or gates. Well, here's a little more description on it. A PWM, pulse width modulation output. So PIDs are not just always linear, but you're going to be turning off how much you're going to turn it off and on during that duty cycle. Yeah, sometimes you have burners you don't just turn them off and on, you pulse them off and on at a certain duty cycle. High speed counters, there's your conveyor where you're counting the cleats. And then here's the high level PID drawing for PID block. Okay. PID is nothing but a proportional integral derivative. And if you ever seen one of these diminishing oscillations that damper her down to nothing, that's what a PID block is. So you'll start off trying to meet the set point, and it'll overshoot and come back, and then overshoot less and come back until it meets set point and it stables out. People get kind of scared of PIDs, but I've had some guys explain them to me, and they're very easy. Multiplexers, just some pictures of some of the functions that we offer. Okay. So that's the PLC. Now let's talk about the HMI a little bit. What is this HMI? You see what that next screen is. This is our offering. We have a 4, a 7, and a 10-inch, which is pretty typical across the industry. Some of these guys who really specialize in touchscreens will have a bigger selection with a lot more on it, but this is our selection. Okay. Here's your general characteristics. Your format, back to the sizes. The TFT graphics display. This is an old resolution from a VGA screen. Okay. Nowadays, on some of the higher end screens, they'll actually give you resolution like your monitor on the computer. But on these touch screens, you didn't need a lot of high resolution on a machine out in the industry. You need information's all you really needed. So you'd have 64,000 colors. Not bad. But lot improvement from the old monochrome days. Resistive touchscreen. That's an improvement that came out about several years ago. I'm just going to say several years ago. I've been doing this for a long time, but several years ago. Used to, they had these cells. It was a grid of these cells, kind of like an Excel spreadsheet. Depending on where you drew the picture, you pushed on the screen, that's what would get activated. But now these are resistive, and you can put these pictures and diagrams and values anywhere on that screen, but you just have to touch within the vicinity of it. Gives you a lot more flexibility for drawing some nice pictures. Gives you LED backlighting for high brightness. IP66. Okay, connectivity. This is, again, where I like to explain the connectivity. You have one Ethernet port, but that Ethernet port can talk some different languages. Modbus is a language. We call them protocols. Modbus, Profinet, I don't know, all the Siemens got their own stuff. Allen Bradley's got their own stuff. Those are just different protocols. Just because it has Ethernet doesn't mean it'll talk on that protocol. You have to verify that. Again, here's your serial ports. You have your RS-485, the old RS-232, right? It's all software configurable. And you got a USB port. Most of them will have all these things. And here's what it looks like on the back. Okay. Modbus, Siemens, S7 Ethernet, OPC. That's another one we can talk about. Here's some communication schemes with third-party devices. You can have our touchscreen, and you can be talking to multiple different manufacturers as long as you're on that Modbus protocol, whether it's Ethernet, Modbus TCP, or RS-485 Modbus RTU. Okay.
So Blake,
yeah.
If you could go back to that slide, the processor modules that you offer in your product line typically have Modbus RTU on an RS-485, but you can use the screen as almost a bridge to Ethernet to the outside world.
Well, you're correct. That screen, anytime I've set up a screen, it was always set up as a master. Okay, so it's a master controller, and it's going to pull these nodes out here on this branch. It's whether it's 485 or Ethernet, it's going to go pull them for data and pull it back into it. So it's the master. I'll go into that here in a second. I'm glad you brought that up because let's look at this next slide. If it's a master, and it's going to be talking, and it can talk to this open platform communication. Okay, this is where you can get into talking as a web server. So yeah, that touchscreen can talk to all these different things through an OPC protocol. Back to the touchscreen, and then or you can do it the other way. You can go right into, here's what I was thinking. They all go into there and then go talk to the OPC client. So what I had out in the field is I'd have one of these touchscreens talking to multiple different machines out there. And then I would take that and send that back up to the central control room where they probably have a SCADA, some supervisory control system set up to monitor the whole plant. If they're doing it through that one master. Now, the advantage of having one master talking to all these things, okay. But the disadvantage is, well, if you lose that master, you lost your whole plant. So we can take that and talk, all these different individual things could talk to that OPC client. It's just different communication schemes, whatever the customer think is most safe or most advantageous to their process. All right, here's some technical characteristics. You can look at the touchscreen, always RUL and all that stuff. The interfaces and just typical. This is every manufacturer is going to have this. I can loosen up down here. Oh, the resolution. Oh, look, the resolution goes up the bigger the screen. Cool. Dimming, yeah, I can dim it. Resistive keypads, most of them are all resistive nowadays. You can flash memory it. So if you get this thing all programmed up, you want to change something, you can put that on flash memory and just walk up to the thing and update it right quick. Now, let me explain a little bit on how these things are programmed. Remember a while ago we talked about in the PLC, you had these bits off and on. Well, as I program this screen in the software, just like you're looking at, that one there, it says I01. I have a picture. We call them widgets. I can draw that picture of that little green thing on there, and I can tell it to change states as that input changes states. So when I turn the program on and you turn that input off and on, I can see that little picture of that light. I can make it look like it's on or off. So now I can get some intelligence out of this thing. For every one of these little dots, every one of these little addresses, every one of these analog input pictures you see, it's got an address. So as you program it, draw a picture of it, you right click it typically, and you go in and you select an address to interface that picture with. This stuff came out back in the early 90s, and I think we called it GUI, graphical user interface programming. So now we're using these pictures. I think you might even see it on Visual Basic. Now you can draw a picture of a button and interface it to an actual output point or input point address in the PLC and have it do things for you. So you can imagine trying to wire up an operator panel with all these meters on it, all these lights on it, and then being able to turn the page and do another one. All that on one big operator panel. That's a lot of wiring. That's a lot of labor. That's a lot of space. But I can just put this one 7-inch touchscreen up there, let the operator turn the pages, have a little index for him. And he can go to different sections of the machine and make things happen. He can even have an alarm section. So if something's going on with his machine, he can go in and get a banner and read a paragraph of what's going on. Okay. Here's some more of these widgets. See that top picture up there? They got meters at the top. They could have used meters like this. Okay. But in the software, we have the widgets, toolbars to go pull them in. You can do data logging, client server architecture. So like we talked about that earlier, you can password protect this so nobody can go change your password once you get it put together. Multilingual, you can do different languages. If somebody comes up and you're building a machine for different countries, you have all that pre-programmed and you just select the language and wherever you send in the machine. Alarm management, recipes. So if you've got a part that's going in, requires a certain recipe of timers, you can set it up right here. You just go select it and it'll readjust all the timers for that particular process. Built-in web server again. So once I get all this program talking, and I want this data at my fingertips, I can hook that into the web and you can log in from anywhere in the world and see what's going on with that process. This is just another breakdown of all the graphics and all the functions of the touchscreen, data logging and trends. You can get reports, you can print reports from it, set up the recipes, multi-languages, scheduling, all that kind of stuff. Just keep in mind, I think the reason I go into this is a lot of people say, cross this touchscreen for me, Blake. Okay. My first question is, how serious is this customer about changing product? Because this isn't like a contactor where you just go pull one out and put one in. You got an engineering, this is an engineered solution. You got to go program all this stuff in there. And it just takes time. It takes time and engineering labor to go in there and do that. Or labor, I shouldn't say labor, the engineer has to put it together. Um, so anyway, yeah. Client. So we have these programs that are pre-built that I can already interface. And it's a diagnostic screen. So if I'm talking to a PLC, I can pull it up on the touch screen to see if it actually sees that certain inputs are off or on, or outputs are turning off or on. These are programs that are just pre-built. If you bought one of ours, it would be a program that you could also just download for free and put it in there. And you're like, okay, but that doesn't really fit my application. That's fine. Build some more screens. Build some more screens, put this in the back on some maintenance page and use it for diagnostics. At least you got to start. And a lot of times I've hooked these things up and I'm trying to see, why won't that output light show up? I've got it turned on. Yeah, but it doesn't think you got it turned on. It gives you an easier way to trace through your program to find out why that thing's really not working. So if I went out there and I looked at, well, that solenoid's not pulling in. Well, the output's on. Yeah, okay. That kind of eliminates, that could be anywhere from the output card all the way to the solenoid. Helps you eliminate problems. Here's the web server where we talked about putting an IP address on there and pulling this data up right away from anywhere in the world. Well, the biggest problem I've had with this is people trying to get through their firewall. Being a Lovato guy, I can't help a guy get through his firewall at his plant. He's got to go talk to the IT guy there locally to see how to do that. Okay, just some more scenarios we've got for monitoring the IO. Some troubleshooting pages Lovato already put together. There's some more of them. And God, look at all these graphs. You got to realize each one of these bar graphs going across there, you have to map that to a certain address in that PLC. It's not like just drawing a graph and having it work. You gotta interface all these things to it. Okay, all these values, 365. They're pulling that out of an online register. I call them registers, a memory location with a value. Okay, there's just another one, pumping stations. We already had this one pre-built for somebody who wants to use it. Okay, just a few more examples. Each one of these bar graphs have got an address assigned to it. You have to go map in. This one here where it says KVAR, there's two places in that one rectangle you got to map. That 54.00, that little spot's mapped into an address, and then this gauge right above it's mapped in probably that same address. So as it changes, they change together. Transfer switches. My gosh, I've never seen so many combinations of transfer switches. And especially when you get into tie breakers and stuff. It's just a few applications. Anyway, it's what I got.
Hey, Blake, could you give us a cost orientation on the three sizes of HMIs that you offer?
Don't know that I got it handy. Um, Let me look and see if I have a file here. I can do it. Let's see. We still sharing the screen?
Yes, you are.
Let's unshare it because I may have to pull up some confidential information.
That's fine. That's fine. Just you can do that up in your.
There it is. I found
There you
it.
go.
Okay. Yeah, let me look. Let me look. It's not open. There it is. We're getting there. Let's click. Okay, so if I'm looking at that 4-inch touchscreen, we have a list price on that for $814. You go to the 7-inch touchscreen, it's $950. When you go to the 10-inch touchscreen, it's $1,900.
And
So
those are all wash down duty. I
yeah,
noticed IP66.
yeah.
How are they meant for outdoor applications? Do they take the UV well, or do we have to put a cover over them if we're putting
You
outside?
probably, I always recommend the cover. Now, some things that have that high brightness, and I don't think we have high brightness on that for outside, and I don't think we have the UV coating on the front of it. I haven't seen anything on that. Um, the
I did
sunshine,
notice. I did
sunshine's
notice you have
devastating.
contrast control.
Yeah,
Contrast control helps when it's outside, but
yeah.
yeah, typically these HMIs, unless you get the hardened ones that are in the $3,000 range, they don't do well outside unless you put a cover over them.
Yeah, I'm a firm believer in that anyway. Went to school in El Paso, and the sun is pretty intense there. Right? It just destroys things. So anytime you can get your equipment out of the sun, put some kind of a shade over it, something. I see people take their electrical boxes and they think it's pretty to paint them on dark green or black. You got to realize when they make those electrical boxes and they got that gray on it, that's a reflective paint that reflects it helps keep the heat off of that stuff. So anytime you put something out in the sun, try to cover it up. Even my swimming pool equipment, I have some kind of a cover over it just to get it out of the sun. It lasts longer.
The other thing I noticed is that your list price is about half of what Allen Bradley charges at a.
Well, you know what they say, you can't pay more than Alabama. They're it's just true. You can't, they're the highest ones on the market. Uh, Siemens might be kind of high too. I don't know. Square D, they're usually not quite as high. But yeah, Allen Bradley's always going to be expensive.
So and the HMIs, they can be used on anybody's PLC so long as you've got the right protocol, correct?
That's correct. And you said it correct. Protocol language is the language they're talking. I wouldn't put somebody down in Mexico who couldn't speak the language. So the same thing. I wouldn't put a touchscreen that can only do Modbus, although it had Ethernet. Wouldn't put it in an Allen Bradley system unless it could talk with the Allen Bradley Ethernet IP, I think is their protocol.
Yes, sir.
Yeah.
One final question. Do we have a starter kit, if you will, that can be used where we buy a certain basic package of hardware for someone to train up and learn?
Well, we have the starter kits on the PLCs. And the touch screens, I don't think we do. I don't think we have a starter kit for it. It's just it's it by itself. And so you can get the software. You can go right to our website and download the software for free, and you can play with it with that online simulator built into it.
Oh, yeah. Okay. Very
A lot of
good.
times I've done that because I want to see, is this making that light turn off and on like I want it to? Is that color right? So that simulator is very helpful, very helpful.
So, is this a correct statement then that if we download that simulator, we can pretty much program up the system before we buy any hardware?
That's correct. I've done that
Very
many
good.
times. Yeah.
Well, that's outstanding. Blake, thank you so much for taking the time to come and teach us today.
My pleasure. I enjoy doing it. I know there was a little bit of mix up on the class, but we'll make something happen if that happens.
Yeah. These things are always a little stressful for me, but as long as the thing kicks off at 7:04 and we do a good class,
Yeah.
then it's job well done. Thank you very much.
Okay. Thanks, guys.
Yeah.
Again, probably see y'all. I might see y'all tomorrow.
Oh, yeah,
I'm headed
sure.
out that way this afternoon.
And okay, so for the class, we are at the 19th, and the class for the 26th is going to be a control and networking class on edge computing and asset monitors from Chad Christopher. And then the next week is September 2nd. Good grief, summer's over, and we will be off for Labor Day. But I wanted to point out that on September 9th, we have a very interesting class on some fascinating motor designs from Nippon Pulse. And Nippon Pulse is the company that manufactures those round rod linear motors, amazing direct acting actuators. Most people think of linear motors in terms of a flat rectangle, and Nippon Pulse designs a linear motor that is actually a round rod, and the coil surrounds the round rod, getting a bit better flux density. And so this is a very interesting class on September 9th. But for now, it's 7:56. Thanks everybody for attending, and time to go to work. We will see you next week.
Thanks, guys.
Thank you, Blake.
Uh-huh.
Thanks, Pierce.
Thank you.
Have a great week.
Thank you.